One thing we haven't talked about yet is, what does it actually mean to send a transaction in Bitcoin? At the heart of this lies public key cryptography. Rather than encrypting and decrypting with the same key, which would be called symmetric cryptography, we have a public key and a private key. The public key is for encrypting data and the private key is for decrypting data. And as you may guess from the name, only the owner is supposed to have the private key. In the context of Bitcoin, we don't really care about the encryption and decryption functionality. But public key cryptography has another feature that we need for Bitcoin, and that is signing data. You can sign any data you want, which will produce a signature. Imagine I own two keys. Key A, the public key, and key B, the private key. And now I can use my private key, key B, to create a signature. And I will also publish my public key, key A, so everyone can now see this key A. With the signature, anyone with key A is able to verify that the owner of key B generated the signature. For Bitcoin, this would be signing data that says, for example, send 20 Bitcoins to Bob. This, together with the private key, creates the transaction signature. Now, anyone can verify that the data sent 20 Bitcoins to Bob was indeed what Alice signed. So you basically just put the signature under any data, and since it's a cryptographic signature, nobody else can imitate the signature without your private key. A Bitcoin address is the public key, and the private key is what users have hopefully securely stored in their digital wallets, which now means we have cryptographic messages indicating money transfers. So when someone is creating a new Bitcoin wallet under the hood, it means a new private key is generated. This key will be chosen completely randomly, and every time you choose a new wallet, a new private key is generated. You might be wondering, how many Bitcoin addresses are actually in the world? And isn't it possible that some people might just generate the same address? Well, the key size used for Bitcoin is 256 bits. What that means is there are 2 to the power of 256 possible different Bitcoin addresses. That might not sound that high, but it's actually this crazy number here. You can see this is a ridiculously high number. And to give you some perspective, this is the number of Bitcoin addresses in trillions. This is the width of the universe in septometers. And 1 septometer is 1 divided by 1 sextillion millimeters. Sextillion is this huge number at the bottom here. And this is the age of the universe in yoctoseconds. And 1 yoctosecond is 1 divided by 1 septillion milliseconds. Septillion being this huge number here, even 1,000 times larger than the previous number. So that should clearly give you some perspective on how insanely large that number is. But maybe you have heard of the birthday paradoxon. If you wished that the candles would stay lit on your birthday cake, would they? Okay, I'm kidding. This is not the actual birthday paradoxon. What it actually is the following. How many people need to be in a single room so that you likely have 2 with the exact same birthday? I'll give you a few seconds to guess a number. Just guess one intuitively. The answer looks like this. And that is surprisingly only 23 people. But how can that be when there are 365 different days? Well, with 23 people, there are 23 times 22 divided by 2 birthday pairs to consider, which is 253 birthday pairs. And that is well above half of all days in a year, which is 182.5 days. So could that mean that we have the same problem for Bitcoin? Because it's already problematic just having 1 pair of Bitcoin addresses be the same. Luckily, even with that, it's still not a problem. I did the math for you, and to have even just a 0.1% chance for a single collision, like the birthday paradoxon, that would mean you need in total 5.4 times 10 to the power of 22 different Bitcoin addresses. If the total Bitcoin computing power would be used for nothing else but generating new Bitcoin addresses, it would still take 700 years combined calculations to generate a single collision with a probability of 0.1%. So I think we're fine.